Let's start recording. Alrighty. So I think it's the 10th. I don't know. My phone's being weird. So I can tell it's the 10th, but I think it is. Homework 6 is due tonight. Just like, okay, it's the 11th. That's what I thought. Because tomorrow's Friday and then Sunday is the 14th. Okay. Homework 6 due tonight. Test correction grades are posted. Homework 5 solutions and exam 1 solutions are going to be posted later tonight. I like to not post the homework solutions for a while in case someone wants to turn in their homework late and still get points for it. So that's why I give some time. And exam 1 solutions are also going to be posted. I need to just change one little thing. So we're going to wrap up 2.3 today, and then we're going to hopefully move on to 2.4. And I think you guys might like 2.4. I like 2.4, but we'll see. Okay. Let's start. Okay, so why are we so zoomed out? Last time we talked about this vending machine, right? If I at a price of $1 per can, he'll sell 600 cans. But for every 25-cent increase, he sells 75 fewer, right? And then from there, we're asked to find a linear model. So for a linear model, we need, Duke, come here. Slope, and we need our y-intercept, right? So M and B. So we found M by finding 2 points. We were given $1. We chose to do things with cents. So 100 cents gave us 600 cans. And then, I'm so sorry that he's whining so much. He is okay. And then for every 25-cent increase, so at 125 cents, we sell 75 cents or 75 cans fewer. So 75 fewer than 600 is 525. So that's how we got our second point to then plug into our average rate of change or our slope definition. They're the same because linear equations have constant average rates of change, and that's how we got -3. All right. And then we made our linear equation using the point slope form because we had a point and we had the slope. It just seemed a lot easier. Okay. So just know we already have our slope. It's -3. Right. So then we were asked how many cans of soda will he sell if he charges 60 cents per can? So or $2, which is 200 cents. So we plugged each of those in for X and we found how many cans we were going to sell. Then I asked you guys in our exit slip to find the slope of the line. And what does the slope represent? Specifically, what that means is what does it mean in terms of the problem? Yes, I understand that slope represents rise over run, but what does it represent in terms of this problem? So after that quick synopsis, can anyone tell me what they think the slope is? The slope of the line that we use. And the equation for the line is kind of above right up here. I think our equation was C minus 600. So what do you guys think our slope of that line is? What form is this written in? Is it written in point or in slope intercept or slope point slope? Sorry. Point slope, right? So I'm given all the numbers that are in this are either going to represent a point or the slope. So which of these three numbers is going to represent the slope? Think about it, -3, right? 9 times out of 10, it's going to be the coefficient in front of X right there. So that's our slope. what does it represent in terms of the problem? If I were to use things like cans and cents and fewer and something like that. How would you tell the vending machine guy? You just tell him your slope is -3. He's not going to understand what that means. How would you describe what that means to him? Or what's a way that we can tell him? Would we say that for every 3 cents we increased, he's going to sell another can? Is it going to be for every, right? So we know for every 25 cents that he increases the price, he sells 75 less cans. I think it's fewer when you're talking about amounts, the difference between fewer and less. So if we were to dial that back to have, we're talking about slope is -3. So we can say for every 1 cent increase in price, oops, he will sell 3 cans fewer, because we're asked to what the slope represents in the same problem we're asked what the slope is. So we don't necessarily want to just automatically say the 25 cents to the 75 can phrase from our problem. We want to kind of dial it back to the number that we got. And if you can just see that that's just kind of like a scaled version of what we were given, right? Instead of 25 cents and 75 cans, it's 1 cent and 3 cans. So it's a proportional thing. Okay. How do you guys feel about that? Because a lot of you struggled to find the slope and I didn't get a lot of response from you earlier. So I just want to make sure that you guys are able to find the slope if you're just given an equation of a line. So thumbs up, thumbs sideways, or thumbs down about it so far. Okay, I see a few sides. Okay. Okay, great. So now, so we found the slope. That's really great. That's usually out of using point slope and slope intercept form, we can 9 times out of 10 find the slope pretty easily. Because both of them have the slope just as one of the numbers. For part D, now we're asked to find the y-intercept of the line. There's multiple ways to do this. There's no one way. So what are some ideas of how we can find the y-intercept of the line? Oops. Right, I can set x equal to 0, right? If I look at, say that's my graph and here is the linear function we're working with like that, our y-intercept is this guy, right? It's a y value because it's when x equals 0, right? X equals 0 is the y-axis. So I'm gonna like, chairs are super squeaky, right? So we're gonna set x equal to 0. So grab my equation from above, c minus 600 equals -3, 0 minus 100. All right. So remember, C is the number of cans that we're selling and X is the price. So when the price is 0, so minus 600 equals -3 times -100. Two negatives, those little negative signs, I always like to think of them of coming together and to make a little positive sign. That's how I always remember it. So I get 3 times 100, which is just 300. And then I move my 600 over and I get C of 900. Okay. So 900 cans, right? So let's just say 900 cans. for problem's sake. We're just to find y-intercept, and that usually doesn't have any units, but for what does it represent, it might help to think about that. Remember, C is cans, okay? So what does it represent if my y-intercept is 900 cans? We set x equal to 0, so that's kind of a hint. What are we thinking? What do we think it means? The y-intercept. I'm asking for D. So right, we found the y-intercept, but we're trying to figure out what does it represent. So I'm just waiting on one of you to tell me. Or what you think. So we set x equal to 0. Think about what x equal to 0 represents and how I can phrase it. So x doesn't mean if we take no money off of the price, x represents just the price, remember? We set x to be the price. And C was the number of cans. Right, so when the price is 0, or you could say free, when the cans are free, he will sell 900 cans. Which probably tells you that's as much as he can probably fit in there, right? And that's it. When the price is this, he will sell that. That's all we need to say of how it represents. You just need to, instead of being like 0, 900, you need to take information from the problem itself and smush those numbers into those words, okay? So now we're finding the x-intercept. So let's learn from part E from what we did in part D. We found the y-intercept of the line and by setting x equal to 0. How can we find the x-intercept of the line? We're going to set C equal to 0, which is also y, our output, if we will. I like to call things C for like cost or something. We called it cans to just kind of help remind us what our variables are, because it really helps when you're talking about what do things represent. So we're going to set C equal to 0. And if you called it y, it would also be y. So we're going to have 0 minus 600 equal -3, x minus 100. I'm going to distribute this -3. So -600 equals -3x plus 100. Negative times a negative. Do not drop that negative. Okay. So then I'm going to subtract 100 from both sides. I'll get -700 equal to -3x. And then I should get, it's not divisible by 3, but I can get kind of close. Okay, it is. So x is going to equal 233.33. Remember, this is in cents. Yeah, we'll just say that we can have cents in there. I said decimals. All right, so what does this represent? If we're thinking about on a graph, it's this guy down here. That's our x-intercept when y equals 0, or output. Ooh, it's hard to say. So if the x-intercept is 233, right? It's the price at which people are going to be like, ooh, $2.33 for a can of soda? No, thank you. Which is honestly kind of expensive. So exactly. So at $2.33, 0.33. No one will buy any sodas. Oh my God, what did I keep wrong by? Any soda cans. I.e., he sells 0. Okay. So great job, Griffin. For getting that. Right. So our intercepts here represent when price is 0 and when our output or how much we sold is 0. And then we can talk about which each of those outputs represents. Okay. Duke, come here. Alrighty. I think that's all for this problem. So how do you guys feel about the can problem so far? Or I guess not so far, but now, afterwards. Thumbs up, thumbs sideways, and thumbs down. Okay, great. A lot more thumbs up. Make me feel good. Wow, my God. I should go take a nap. Right, so the phrasing part, it's hard. And that's hopefully where homework comes in to get a little bit more practice, especially when doing it online, because you can do kind of a few more and they'll, I think sometimes give you like a little multiple choice of how to do it. You know, it can give you some good ideas of how to phrase things that you might not have seen before. So now we're going to move on to vertical and horizontal lines. So if you're like me and don't know your left and rights very well, it's easy to mix up vertical and horizontal lines. Don't even talk about longitude and latitude, confusing. Vertical lines up and down, horizontal lines like the horizon. That's the only way I can remember is the horizon is this way. So the horizontal lines go this way. And also if you think about like the Z in horizontal, it has 2 sideways lines in it. Where vertical, like the V is like 2 up and down lines. Another way to remember it. But basically a vertical line that passes through the point AB. So remember a vertical line, it's going to be, I need to, make sure I don't write this wrong. It has the equation X equals A, right? So it's a vertical line. So if I were to draw an axis, that was cool. And let's call this the point AB. A vertical line that goes through it is just going to be, let's do a different color, this line. Right? It's vertical and goes to that point. Right, and so it also hits this point, the x-intercept, so that's when y equals 0. So that's that other point. All right, so that's the equation for our vertical line, x equals a. Now a horizontal line that goes through AB has the equation. Does anyone know what it might be? I want to see if anyone might guess. Yeah, it's gonna be y equals b. And I'm actually going to draw this on a different one so we can talk about each one of them, because I also want to kind of tell you a fun way to remember this. All right, and that's going to be 0b, that point. Alrighty, so why do these equations make sense? So we're using the word equation really carefully here, not the word function, because we're only given one variable X or Y. A and B are obviously constant numbers. Beginning of the alphabet numbers are usually coefficients, and actual numbers where X and Y and Z, W, things in the later alphabet are variables. So we only have one variable that is in each of these equations. So I can't have one variable in terms of another helping me create a function because I only have one. So why does it make sense that the vertical line is X equals A and the horizontal line is Y equals B? The way I like to think about it is that on this line, every point, right, I look at the X, I know it's going to intersect the X axis, right? And it has a 0 because the X axis is when Y equals 0. So that means that every X coordinate of the points that are on this line have the X coordinate of A. And it doesn't matter what B is because it's horizontal. It's vertical. For horizontal, we have Y equals B, which is pretty common. You might, this one's a little bit more easier to see. What's the slope of this guy right here? What would you guys say the slope of my horizontal line is? It's 0. Careful, Ronald. It's not undefined. It's 0, right? If I think of like Y equals mx plus b, well, I just have Y equals b, so that makes m 0. Also, a flat plane, if you just think of like the floor that you walk on, that has a slope of 0. A slope doesn't exist, or what Ronald said is undefined. Both of those terms are synonymous. Meaning I can't walk on that slope, right? I'm not Spider-Man. I can't walk up a wall. I can't walk straight up this way. I can walk here, but I can't walk this way. Doesn't work like that. So that's when we say that the slope is undefined, and we can see that here because we're given like Y equals mx plus b, but I don't have Y at all. I don't even have this side. So I can't, I'm just rising up. And since it's rise over run, I'm not running over anywhere. So I would just get like, I get like b minus 0 over a minus a, which is b over 0. And I can't divide by 0, so it's undefined. And it's undefined everywhere because it's a constant. So that's the difference between vertical and horizontal lines. And that honestly is what helps me. I have to like, it's not really quick to me of like, oh, vertical line is X equals, horizontal line is Y equals. I need to make this justification in your mind, which is why we kind of build up to all of these things so that if you like get tripped up on something, you have all this other material and knowledge to fall back on to create these tools for yourself to help your thought process through these problems. All right. So horizontal line, I can walk on them. It has a slope, and that slope is 0. So then I can deduce Y equals B. And then if you just want to remember that one and be like, the vertical line is the opposite. It's going to be X equals. And notice that X equals the X coordinate and Y equals the Y coordinate. I think that's pretty clear. Alrighty. Does anyone have any questions about vertical and horizontal lines? Okay. All right, so now we're going to talk about when is the graph an equation of a line? Do I have this section in my notes? Ooh, 1 second. I need to pull something up. While I'm doing that, think about if you have any questions about vertical and horizontal lines. Oh, there it is. Okay, there we go. Okay, so remember how at the beginning of 2.3, I said that we have 3 different ways to write an equation of line, and I gave you 1 and 2. So now we're going to talk about number 3. Oopsies. All right, so we've seen many different ways to write an equation of a line. And we can take both of those forms and move some things around, and we're going to call that the general form of the equation of a line. Right, so I had point slope. I could take a point and I could take the slope, smush them together and make that form. I could take the y-intercept and the slope, smush those together. But now I have the general form, which doesn't tell me, what do I do? Like, do I use the slope? Do I use intercept, y-intercept? And you kind of have to pick and choose what you use, because the general form is ax plus by. I like to use capital letters for these, plus c equal to 0.
It's black, it's frozen.
Sorry, that scared the crap out of me.
Sorry.
Can you guys see it now?
Yes, ma'am.
Sorry. I was on a different screen and I forgot that it pauses mine. Ooh, that spooked me. So ax plus by plus c equals 0. So basically we're just moving everything onto one side and setting, and so that one of the sides equals 0. And just like before, we don't really want like one big fraction. Remember how we had that problem earlier? We want a number times x plus a number times y plus another number. And we're told where a and b, where both a and b are not 0. Okay. So the reason, does anyone know why both a and b cannot be 0? It's just because if they were both 0, then you just have c equals 0, and that isn't always true if c is not 0. So that's why. All right. So for the linear equation, I think we just have 2. Yeah. Thanks for this. So for the linear equation, 2x minus 3y minus 12 equals 0, we're asked to first find the slope. All right. Again, there's multiple ways to do this. But I think there's more of an efficient way. So does anyone have any ideas of how we can find the slope of this line? Right, we can get y by itself, right? So in turn, kind of making it look like, I'm going to take the general form and I'm going to make it look like slope intercept form. Remember, slope intercept form is y equals mx plus b, right? Intercept, don't know what that is, form. There we go. right? So we're gonna have 2x minus 3y minus 12. So I'm gonna move equal to 0. All right, I'm gonna add 3y to both sides. It just makes your life a lot easier, especially when there's a negative. So we're gonna have 2x minus 12 equal 3y. Then we're gonna divide everything by 3. And I'm also just gonna flip it over because I usually like it into y equals. So y equals 2/3 times x minus 12 divided by 3 is just 4. All right. So we got it into y equals. So we made it into slope intercept form. And that helps us out also when we're doing part B. So looking at our slope intercept form, can anyone tell me what the slope of our line is? It's 2/3. So we're going to say the slope is 2/3, right? And that's it. Now we're asked to find the x and y intercepts, which is another reason that using slope intercept form was very useful because it also shows us one of our intercepts. Which intercept does this show? Does it show the x-intercept or the y-intercept? I don't know. I just got chocolate on my tablecloth. You're right, you get those our y-intercept, right? Because we set equal to x equal to 0, we just get y, it's -4. So and then y-intercept. Intercept. So what's our y-intercept? Right, it's -4. Don't drop that negative. So we can say our y-intercept, you can say it's y equals -4, -4. Remember, it's a y value, just like local max and min is just a y value. It's not that point. Alrighty, the x-intercept. How can we find the x-intercept here? It's not easily seen in our equation of the line. So what can we do? We can set y equal to 0. Should we set y equal to 0 here or up here? It doesn't matter. It's just whatever you're more comfortable with. Let's do the general form, right? So we're given 2x minus 3 times 0, setting y equal to 0, minus 12 equals 0. So then we're in 2x minus 12 equal to 0, 2x equals 12, and x equals 6. And that is our x-intercept, right? Hold on. Did I do that right? Yeah. Yeah. Okay. All right. So don't forget about the general form. You're going to be asked to like find the line between these 2 points and write it in this form. Okay, now find the line with this property in this form, and so on. So these 3 forms are really important. The general form isn't too common in just normal practice. Slope intercept is my favorite. But point slope is the easiest one to get if you're just given 2 points. All right. So we're going to be done with 2.3. Does anyone have any final questions about lines? Okay. Sick. Now we're going to move on to 2.4. If I have it, there it is. All right. It is Thursday, March 11th. Ooh, I'm getting my vaccine in a week. Okay. So now we're going to talk about varying the coefficients. So varying slope, varying my intercept, and things like that, and what that causes. All right. So, right, the coefficients, you guys have heard me say this word before. Of the linear equation y equals mx plus b are m and b. Right? Because x and y are variables. So everything else, coefficients. The constant coefficient is b. Right? Just b. The coefficient, so m is called the coefficient of x, right? So usually just like coefficient of x just means that number in front of x. Constant coefficient, it's just like chilling out by its own. It's a constant number. Came to the party alone. So constant, if it's just a number by itself, coefficient of x, it's came with x, m and x, they're like BFFs, okay? So is that clear, the difference between a constant coefficient and a coefficient of another variable? Like thumbs up, thumb sideways. Okay, cool. So I want to make sure you're still paying attention and not like using me as like a background noise to do something else. All right, cool. So now we're asked to sketch the graph of y equals, b plus 2x, right? So for b equals -1, 0, 1, 2, and 3. So let's draw a really big axes. That is not even good. One of these days I'll learn to put these in our notes already. Okay, there we go. Right, so this is our x-axis, x, this is our y. Draw some little lines. Okay, great. So we're asked to sketch this graph. So the coefficient of x, m, our slope, is the same, just 2. But now we're just changing b. All right, so this is where my super fun colors come in. Let's do b equals -1 and this fun color. So that means my y-intercept is -1. So go down one little notch right there. And then a slope of 2, rise over run. I'm going to rise up 2 over 1. And I'm going to draw the line. I also like to do another one. Run down 2, run over 1. There we go. I don't like that. Okay. So a line like that. Okay, so that was b equals -1, right? I had my slope right here, not my slope, my intercept right here, and so on. So the next one, when it's 0, let's do this blue. Now, y-intercept 0 just means I'm right here at the origin. Go up 2 over 1. Oopsies. Draw this line down here. Okay. And that line goes on forever. So that was b equals 0. And we're going to keep continuing this. Let's do 2. That'll be our last one that we draw. 1, 2. Okay, these are supposed to be. There we go. All right. Do you guys see any fun, like what do you notice about all these lines? Right, they're parallel. And we're going to talk more about, no, we're going to talk about that in a hot second. Right? So all of these lines are parallel. So we say that 2 vertical lines with slope M1, M2 are parallel if and only if M equals 1 and M equals 2. So they have the same slope. All of these guys on these different colored lines that kind of look like Powerpuff Girls, they have the same slope too, but they just have different y-intercepts, right? What's another way? Oh my God, my pumpkins are in here. I did this lecture last year in October and I found out how to put pumpkins in all my notes, and there's some ghosts and witches mixed in there too. What's another way that we can kind of quantify what it means to be parallel? What are some properties of parallel lines other than their slopes being the same? I know, sorry, Clayton, I rushed you into that one. Other than their slopes being the same. That's not really a property, that's like the definition, right? They never intersect. Go to Griffin. You guys are on top of it today, right now. This is great, right? So they never intersect. Ever. Go off into the infinities and negative infinities, they're never gonna intersect. All right. So if we let pumpkin be a line with the equation y equals 4 minus 3x, find the equation of a line parallel to pumpkin passing through 2, 0. All right. So in the previous section, we were told, hey, here's this slope, here's this point, find a line, or here's 2 points, give me a line, something like that. Now I'm given another line and a point. Ooh, I can't find the slope with just 1 point. So what should I do? I want to find the equation of a line specifically that is parallel to this first one. This is pumpkin right here. And it passes through 2, 0. So what do I do? Oh, I'm given a point. How'd you get there, Griffin? Gotta show me some work. And while you're telling me how you got there, I'm gonna go get my laptop charger. 1 second. How did we get that line?
Can I just say it?
Yeah.
So sorry about that. I know that at x equals 2, y equals 0. So no. Yeah, at x equals 2, y equals 0. So 2 before that would be the y-intercept, because 2 before x equals 2 is 0. So I just took -3 times 2 and made it positive. I don't know how it made sense in my head, but is it
Okay? Here's a good question, because I think you know what you're doing, but you don't know how to say what you're doing.
Yeah.
You're doing a lot of steps in your head that you don't think are, that you might think are intuitive, but kind of need to spell out. How do you know to use -3?
It's the slope. And well, it's parallel.
Yes, because it's parallel, right? So our slope of our new line is going to be -3 because it's parallel. It's parallel. It is parallel. There we go. Oh my God. Parallel has 3 parallel lines in it. All those L's, right? So so we know we were using -3, right? And then Griffin does what I always like to do. I like my equations as like y equals mx plus b, and then I just plug in this value. So we got like 0 equals -3 times 2 plus b. So you get that 6 is equal to b. That's what I like to do. If you wanted to put it in this form, slope-intercept form, or we already have a point that goes through that line. So we can just easily do point slope, right? So y minus 0, -3x minus 2, which just will give us y equals -3x minus 2. That's another way of writing it, which you can see is just the same as that. Was that kind of what you were saying, Griffin? I didn't mean to take words out of your mouth.
Yeah, that's what I think I did in my head. I don't really know how I
No, it's okay. Thank you for volunteering. So both of these equations are the same exact thing. It's just whatever way you prefer doing it, right? Sorry, I gave Duke a bone now, he's eating it. Both of those are the same line, which you can see if we just distribute that -3. Okay, so if I'm told something is parallel, I automatically take its slope, and I'm gonna also be told that it goes through some other point. So yeah, okay. Does anyone have any questions about how we got that line? Because we're gonna move on to a classic math problem of 2 trains leaving somewhere at one point at 2 times at 2 different speeds. Okay. So 2 trains are heading north along the California coast on the same track. Ooh. The first train leaves this beach 25 miles north of San Diego. So automatically, this is a lot of words, a lot of numbers. I'm going to highlight all my numbers. So 25 miles north of something at 8 a.m. And I'm going to start drawing a picture. So it's going to be north. So I'm going to draw it vertically. Those are my train tracks. Right. And if this is San Diego, we'll say this is 25 miles. So one train is starting at this point. Choo-choo. Little smokestack coming out of there. Actually, no, we're just leave it like that. Okay. And the second train leaves, say, whatever, 58 miles north of San Diego at 9 a.m. Each train maintains a constant speed of 80 miles per hour. Great. So they're both heading this way. So the other one is like all the way up here. And they're both going this way. But the second one isn't leaving until 9 a.m. Okay. So for each train, find the linear equation that relates its distance, y, so it tells us our variables, which is, I would love when problems do this. Our distance is y from San Diego at time t. So what we're not told is when time is 0. So you can either make time start at the first time that you're given, 8 o'clock, or we can make it at midnight. So then like 8 a.m. is t equals 8. It changes the problem. You just need to be consistent. So the first thing to represent, I'm going to move 25 miles out of my way. First thing that we need to find a consensus on is what is t equals 0. Yeah, sorry. What time of day is t equals 0? Is it going to be 8 a.m. or is it going to be midnight? There's no right or wrong answer. I'm just asking you to decide. $8 a.m. Okay. That's usually what I would do too. Okay. I wouldn't recommend making it noon because then you'll start at like -4. That's kind of confusing. That's just a recommendation. So we're going to say it's 8 a.m. So, train 1 is going to be this maroon train. So let's go back and highlight these things, and I double highlight. Okay, you can't really see that. I know color coding might look silly, but I swear it's very helpful. I'm gonna do some maroon orange because I feel like being collegiate today for my school. Okay, cool. So our first one is gonna be 25 miles north, and second one is 58 miles north an hour later. And they both have a constant speed of 80 miles per hour. Okay, cool. So, for our first train that starts 25 miles north at 8 a.m., how can we find an equation for that one, for train 1? We already have a point for it, right? What's our point that we're given? If we chose t equals 0 to be 8 a.m. and at 8 a.m. it's 25 miles north, y is the distance from San Diego. So what point do we have for this line already? Come on, I need some answers. Right, we chose t equals 0 to be 8 a.m. So at 8 a.m., train 1 is 25 miles north of San Diego, right? 25. So we have 0, 25 as a point. That's great. Careful on it. We're talking about train 1, not train 2. Train 2 is going to be 58 miles north of San Diego at 9 a.m. So close, no cigar. So now I have a point. How do I find my slope though? I only have 1 point. What do you guys think my slope's going to be? It's like pulling teeth. Am I told my slope at all, or do you think I'm going to have to find another point and find it? It is the same as train 2. Ron says we're going to find another point. How do I find another point? It is the same as train 2. So once we find the slope, we don't need to find it again for train 2. How do I find another point? Or do I need to? So what if I told you we don't need to find another point? We're already told it's at a constant speed of 80 miles per hour. Yeah. right? So I'd add 80 and then I'd add an hour. So I'm just adding 80 over 1, right? It's mile per hour, so 80 miles for every hour. We're working on train 1 today, so we don't even want to look at train 2 right now. Hi, thank you. My knee got licked. Okay, cool, right? So we have a point and we know that m equals 80 because we're given 80 mile per hour speed. And specifically told that it's constant. So that automatically tells me that this is a linear equation, right? Constant rate of change, a line. So with that, we'll get y minus 25 equals 80. T, remember we're asked to use time and t, so you need to use the right variables. T minus 0. So I get y minus 25 equaled 80t, or y equals, 80t plus 25. Okay? And just for, this is train 1, let's just call this y1. Okay? Is everyone clear of how we got there? Okay. Anyone else? Clear. Okay. So for train 2, I'm told that each train is at it. So I already know that m equals 80, but what's my point for train 2? It's 58 miles north of San Diego at 9 a.m. I made t equals 0, 8 a.m., and then we're just assuming every increment is an hour. So at what time am I going to be 58 miles away? What does t equal at 9 a.m.? 1, right? Good job. So, because it's at 9 a.m. So now I have my slope and my point. So I'm given y equals, sorry, not y equals, y minus 58, 80, t minus 1, which is y minus 58, 80t minus 80. So I get y equals 80t 58 plus 2, give me 60 minus 22. Yeah. And we're just going to call this one y2, just so sometimes I don't want to like, whatever. Anyways, so I've been given these 2 lines, right? Now we're asked, so great, I answered that. I found linear equations that relates for both trains. Now I'm asked, will the trains collide? $58 is a y value, CJ. That's why it's like y minus y1 minus our slope. Not minus our slope, minus the y coordinate of our point. So that's why I put it here. And then I added it onto, oh, I did forget my 8 EDT. Thank you, Ronald. Yeah, no, they're not going to collide. Right, they're moving at the same speed. So as long as they're not starting at the exact same time on the exact same track, which would be impossible. I don't think you just put a train on top of another train. No. We can say, oh, I don't know where that I goes. They're linear. We weren't asked why, but we're just going to tell you why now. So their linear equations are parallel. So They never intersect. I think, hold on, there's one important thing that I want to bring up about parallel lines, because we say they never intersect, but that isn't 100% true. Let me make sure I'm going to say this at the correct point. Okay, I'll leave that as an excessive question because I want to know your opinions. Okay, cool. So now we're going to we're done with changing our constant coefficients and changing our y-intercepts. As you can see right here, I have different ones, plus 25 and minus 22. Now we're going to talk about perpendicular lines, right? So varying the coefficient of x specifically, right? So, let me make sure I'm bringing this right. Okay, yeah. So two, again, non-vertical lines, because we want to talk about M here, are perpendicular. Let me move back to my green. That means they form a 90-degree angle if and only if the slopes are negative reciprocals of each other, right? So I'm just going to flip it upside down and negate it, okay? So if my slope M is 2, a slope that would be perpendicular to it would be what? Oh, sorry, let's froze again. Right, so two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. So if my slope is 2, right, it would be negative 2. And similarly, if I was given like M1 equals negative 2/3, what would be the slope that would make a line perpendicular to it? It's a negative reciprocal, negative 2/3. Right, just positive 3/2. I'm just going to flip it upside down. So 2 and 3 switch places, and I'm going to get rid of that negative. All right. That negative sign is really, really important. And that's kind of because if we think about perpendicular lines is, draw my axis. Our favorite perpendicular lines are the axes themselves, but one of them is vertical. So it doesn't fit the definition because you can't divide by 0. And that's why they're non-vertical. So if I'm given this like one guy that's going this way, notice that he has a positive slope. So M is greater than 0. Well, to form a 90 degrees, I would need to kind of be like something like this, right? Let's see if I can make this to a 90 degrees. No, one more time. There we go. See that 90 degrees? But then that red line has a negative slope. So that's kind of like the graphical reason that we need the negative there. Okay? Does that make sense? That negative is really important. A lot of people just give me the reciprocal instead of the negative reciprocal. So don't forget your negative. Alrighty? Oh my God, there's more witches. One second. Okay. I really like these little witches because they have little stars and they also have a little kitty on their brooms. And I just think they're really cute. I also just love Halloween. All right, cool. So we let the witch be the line for the equation y equals 2x minus 6. We're asked to find the equations for the line that passes through 2, 0 and is parallel to it, and for the line that passes through 2, 0 and is perpendicular. Okay. So let's do the parallel one first. So let's call that slope M1. What do we think the slope of the parallel line is going to be? We're trying to find a line parallel to 2x minus 6, or y equals 2x minus 6, right? It's going to be 2. And I'm already given the point that it goes through. It's 2, 0. I'm given a slope. I'm given a point. Let's use point slope. So y minus 0 equals 2x minus 2. So y equals 2x minus 4. You could have left it the first way or the second way, either or. All right. For our perpendicular one, what's our slope going to be? Our point is the same, 2, 0. See, it's not 20. Right, it's negative 1/2. 1 over 2. You don't even have to flip the fraction. It's really easy. So now we're going to, again, a slope, a point, we're going to plug in point slope. So I get y minus 0, negative 1/2 x, oops, parentheses, minus 2. So I get y equals negative 1/2 x plus, I want to ask you guys what you think 1/2 times 2 is, because a lot of you were telling me on your exam it was 0, and it is not 0. It's 1. I meant to harp on that at the beginning of class. All right, so plus 1. Don't tell me that 2 times 1/2 is 0. I'll be very sad and concerned for you. Okay. Any questions about finding parallel and perpendicular lines? How are you guys feeling about them? Thumbs up, thumbs sideways, or thumbs down? Okay, cool. Alrighty. So, you might have heard this before of direct proportionality. So we say that y is directly proportional. Okay, hold on. That's not going to fit. Is directly proportional to x if y is just equal to some k times x. So it's directly proportional to, so it's just, it's a multiple of it, right? It's not plus another constant like moved over a smidge, right? And that constant k is called the constant of proportionality. Okay. I think you guys have you guys ever heard of direct proportionality before? And you guys might have also heard of indirect proportionality, where you just divide by x instead of multiplying. All right. So this is our last problem. So we're going to get through this in 5 minutes. And then I want to ask you a very fun question. A solar electric company installs solar panels on roofs of houses. Super cool. A customer is informed that when 12 solar panels are installed, they produce 2.4 kilowatts of electricity. Wild. So part A says if the electrical output is directly proportional to the number of solar panels, find the equation of proportionality. So we're said it's kind of like y is a function of x, x is a function of y. Y is a function of x means like y equals something. So y is directly proportional to x means y equals k times x. So whatever variable is stated first is the one that you want to be that equals, okay? So electric output is directly proportional. So electrical output is directly important to the number of solar panels. Oopsies. So let's call y our electrical output and x the number of solar panels. And we're told to find the equation of proportionality. Well, I'm only ever given this itty bit of information. I only know how to find the slope of a line between 2 points. I only have one though. I'm given, this point is x is solar panel, so 12, 2.4. But I know since I'm told that it is directly proportional to each other, that it's going to be y equals kx. I have an x, I have a y, that leaves me with one unknown, and that's my constant. So I'm going to plug in my point to the equation. Okay, so I'm given 2.4 equals k times 12. I want to solve for k, so I'm going to divide by 12. And I should get 0.2, I think. It's 24 divided by 12 is 2. Yeah. So I'm given 0.2 is my constant of proportionality. Am I moving too fast for anybody? So with that k that I just found out, I'm going to plug in into here so that I'm given, here, let me do it on the other side. Y equals 0.2k. So basically what I'm told with direct proportionality is that I don't have a y-intercept, which kind of makes sense when we're talking about this problem. If I don't have solar panels, how am I going to get energy from the sun? If no sun, how no solar power? Right? I love those jokes. I think they're so funny. So I don't need 2 points. I'm kind of already told what my y-intercept is. It's 0. So I'm already given, I'm secretly given that 0, 0 is a point. Okay? Does that make sense? All right, cool. And then with that, we can just be given how many kilowatts of electricity, so our electrical output, are produced by 16 panels. Right? So I don't know what this was supposed to be right here. All I need to do is just plug in for x. So 0.2, 16, and I think I'd be given 3.2 kilowatts. And that's it. So direct proportionality tells me that my y-intercept is 0. My y-intercept is when x equals 0. So I'm given the already kind of secretly given 0, 0 is a point. And then I can plug my point into this equation and I get my constant of proportionality, which is also just our slope. And we're done. It's pretty cool. All right. So I want to keep this up a little bit, but I want to ask you guys a really good exit sum question. Exit slip. Remember, it's like BL. I haven't opened it yet, so wait 1 second. So after you tell me about how you feel about today and what we learned, I want you to answer the teacher question, which is, how many times can 2 lines intersect? I really love this question. Okay, so let me open our exit slip. Okay, now it's open. So how many times can 2 lines intersect? I'm not telling you anything about the lines. Just there's 2 of them. And then you guys are free to go. Ooh, yeah, Griffin. Oh, let me stop recording.